started for today. So what we're doing today is kind of picking up from where we left off yesterday, solving systems of linear equations by graphing. And today we're actually going to solve them by graphing because we worked with them yesterday a little bit. And the first thing we did was we talked about a solution for a system of linear equations is an x and y value that make both equations true. And we went through and plugged some in and determined if they were true. Then we also looked at graphs where they had graphs already drawn for us, and the point of intersection where the two lines crossed was the solution. Now what we're going to be doing today is actually graphing the two lines and finding that point of intersection. Can we look at this here? We're given equations and we're given a graph. So what we need to do is we need to graph the two equations. Now both of these equations here are in the form y equals mx plus b, where m is the slope, our rise over run, and b is the y-intercept. So we have our slope and y-intercept, and we're going to use those to graph the equations of the line. Now the first equation that we're going to look at is this one here. Y equals negative 2x plus 5. And when I look at this here, the negative 2 is the slope, and the plus 5 is the y-intercept. So plus 5 is a y-intercept, so I can go on the graph and go up to positive 5 and make a point. Because for this equation, y equals negative 2x plus 5, the plus 5 tells me it intersects the y-axis at positive 5. So this one here, 5 is the y-intercept. Now the slope is negative 2. And again, slope is rise over run. And when we just have a negative number, a whole number, it's talking about how far it goes up or down. So really the slope for this top one here is the same as negative 2 over 1. So from this point here, we're going down 2 and right 1. And we can do that again. We can go down 2 and right 1. And we can keep doing this over and over again to get this equation of a line. So we found the y-intercept at 5 because of the plus 5, and then we use the slope, which was negative 2, so it goes down 2 and right 1. And we got our line. Any questions on how we graph the equation of a line? Okay, now let's look at the other equation, y equals 4x minus 1. Now for the second equation, the minus 1 tells me that the y-intercept is at negative 1. So I go down to negative 1 on the y-axis, and I would make a point. Because it told me the negative 1, the minus 1 is the y-intercept. It is at negative 1. Now our slope is coming from the 4x, the 4. So our slope, the rise over run, is going to be positive 4. So it's going to be going up from here. And more specifically, it's going to go up 4. So from here, we're going to go up 1, 2, 3, 4, and over 1. And we could do it again, or we can go down. But this here is the equation of the line. Any questions on how we graph these two lines? Any questions on anything we've done thus far? Now we're looking for the solution, the x, y value that makes both of these equations true, and we're looking for where they intersect. Well, they intersect at this point here. This is the point where they cross. And the x, y value for that point is going to be what? 1, 3. So the point 1, 3 is the solution for this system of equations. So that would be our solution. Now what we could do is I can check this. So I'm going to erase all this here. And if we plug this in, 1, 3, so for the top one, we do 3 is equal to negative 2 times 1 plus 5. Well, negative 2 times 1 would be negative 2. And negative 2 plus 5 would be 3. It works. We could do the same thing with the bottom equation and say 3 is equal to 4 times 1 minus 1. Well, 4 times 1 is 4, and 4 minus 1 is 3. They both give us true statements. So these here are the equations. This is the point, 1, 3, is the point, the solution for the system of equations. Questions on this here? Okay. I'm just going to keep drawing lines. Let's look at another example. So again, with all these here, we're going to be graphing them using the y equals mx plus b to find the point of intersection. So when we look at this here, y equals negative 5, or negative x plus 5. This here is our first equation. And then our second equation is y is equal to 2x minus 1. Now again, we're still referencing y is equal to mx plus b, where m is the slope and b is the y-intercept. M is going to be our slope, b is going to be the y-intercept. So when we look at this first equation here, y is equal to negative x plus 5. Well, the slope is negative 1. The y-intercept is 5. Because of the plus 5, we know the y-intercept is 5. So if I'm going to graph this, and we'll graph this one first, the y-intercept is going to be up at positive 5. And that's where we can make our first point. Because the slope is negative 1, and well, really not the slope, but the y-intercept is 5. Our plus 5 tells us what the y-intercept is. Now the slope, m, is negative 1 for this, so our rise over run. Since it's negative 1, we're going down 1 and over 1. Because whenever we're not really given a fraction, if we're not given a fraction, the left and right, our run is always going to be 1, and the number is just going to be how far we go up or down. Because it's negative, we're going down, and we're going down 1, right 1. And we can go down 1, right 1. And we get this equation here. We're just going down 1, right 1, over and over, because the slope is negative 1. Are there questions on this here? No? We're good? You're good? And that's all we've needed to do to graph the equation of this line. Now we're going to do the same thing for the other one. Now for this one here, our slope would be what? What would the slope of this line be? 2. And the y-intercept would be negative 1. So on our graph, we'll do the y-intercept first, which we know is negative 1. So we'll go down to negative 1 and put a point, because that is the y-intercept, the point where it crosses the y-axis. Now the slope is 2. And since it's positive, we're going to go up 2, 1, 2, and over 1 to the right. And we can do it again. We can go up 2 and over 1 to the right. And we can keep going like this and get our line, our equation of the line. Now, luckily with Big Ideas Math for the program, as long as you get 2 points, it'll create the rest of the line for you. It'll draw the whole thing if you're needing to graph it. But most likely, it's just wanting this point of intersection. And our point of intersection for this problem here is at what? 2, 3. So the solution for this is the point 2, 3, where x is equal to 2 and y is equal to 3. We're looking for where they cross. Any other questions on this here? Are we good with this problem here? Yes? Okay, let's look at another one. Let's keep doing these. Let's see. Let's look at this one here. I want to skip that one. We're going to go to this one here because the slopes are a little bit different. Slopes are a little bit different for this problem here. So we have two equations. We want to graph them and see where they cross on the graph. So our first one here. So we're going to find the slope and the y-intercept. And again, this is still written in y equals mx plus b. So it's a little bit easier to graph because it's already given us the slope and the y-intercept. And we look at this here, the slope for this first equation is what? It is 1/2 because the slope is front of the x. So since we have 1/2 x, the slope would be 1/2. Now the y-intercept comes from the plus b, and the b value for this is 3. So the y-intercept is positive 3. And again, now that we have the slope and y-intercept, we can start out at the y-intercept. So I'd go up to 3 on the y-axis and make a point. Now this time they did give us a fraction. And when we have a fraction as a slope, it's always rise over run. So the rise for this is what? 1, and the run is, so we would go up 1 and over 2 to the right. It's rise over run. And because it's positive, we're going to go up into the right. So we could do it again if we wanted. We can go up 1 and over 2 to the right. We would make our line. Any questions on this here? Okay. Now let's look at the other equation. This one here. So we look at this one here. The slope is going to be what? Negative 3/2, yes. And the y-intercept is negative 5. So our y-intercept's where we're going to start out at, is we're going to start out right here. Now, because the slope is negative, we're either going to go down or to the what? Left, because down and left is negative. Now, we can't go down from here because, well, we don't have the graph there, but I can go up. I would go up 3, 1, 2, 3, and then would I go 2 to the right or 2 to the left? Left, because left is negative, yes? So I went up positive, and I need to go left to the negative. Does a positive and a negative make a negative? And we can do this again. I can go up 1, 2, 3, and over 1, 2, and make our point. And we're going to run out of graph. Then we have this here. Now, do we have a solution for this here? It'd be the point where they intersect, and they intersect at negative 4, comma 1, where x is equal to negative 4 and y is equal to 1. That is the point where these two intersect, the solution for this system of linear equations. Any questions on this here? We're going to look at another one here. So we have y equals 3x minus 4, and y equals negative 1/2 x plus 3. So again, we're still using the fact that y is equal to mx plus b, where m is the slope and b is the y-intercept. So for our top equation here, for y equals 3x minus 4, what would the slope be? 3. It would be positive 3. And the y-intercept would be negative 4. So if I'm graphing this, where would I start out at? Negative 4 on the y-axis, because I'm always going to start with the y-intercept. Because our b value is the y-intercept. It's where it crosses the y-axis, where this line crosses the y-axis. Since b is negative 4, it's going to cross the y-axis where y is equal to negative 4. Now from there, we're going to use the slope. So what would be our rise? Would we go up or down? Well, we can't go down, but we would go up because it is positive. So we would go up how far? 3. 1, 2, 3. Now where do I go? I would go right 1 because, again, it's positive. Since I went up positive, I have to go to the right, which is positive. Because a positive and a positive would make a positive. Positive and positive makes a positive. Now, if I had to go down 3, I would have to go where? Left 1, because a negative and a negative make a positive. So if I go in a negative direction and I need it to be positive, I need to go in 2 negative directions, down and left. Now we could do this again. I could go up 3, 1, 2, 3, and 1 to the right. And 1, 2, 3, and 1 to the right. And get this line here. Any questions on this here so far? Okay, let's look at the other line. Y equals negative 1/2 x plus 3. So what's our slope? Negative 1/2, negative 1 over 2. And this y-intercept would be 3. So where do I start with this here? We will start with the y-intercept, and the y-intercept is 3. So I would go up to 3 on the y-intercept, on the y-axis. And then where do we go next? Okay, and to the well, we could keep going, but really, what am I looking for? The intercept. Did we find an intercept? Or, well, not intercept, we were finding where they cross. We already found that, yes? I don't need any other points. So the intercept is at the point 2, 2. The intercept at the point 2, comma 2. Are there any questions on this here? Any questions on anything we've done so far? Okay. Y is equal to negative 2x plus 2, and y is equal to negative 2x minus 2. And we're going to find the solution, the point where they intersect, the point where they cross. So let's start out with the top equation. Slope, y-intercept. So what's the slope? And the y-intercept is? Okay, what would I do next? On the y-intercept. So it'd be on the y-intercept. We wouldn't do the positive 2 on the x. Now the slope is negative 2. So from my y-intercept, where do I go? How far? Not quite, because the number on top is the rise. So up and down. The bottom number would be the run. If it's a whole number, the run is automatically what? 1. If it's a whole number, the run, how far we go left or right is automatically 1. So negative 2 tells me I go down 2, and which direction? Since I went down, is that a positive or negative direction? It's a negative direction. my slope is what? Positive or negative? Negative. So if I went down negative and go to the left, which is also what? Negative. And negative and negative would make a positive. So since we already have the negative, we have to go in what? A positive direction. So we have to go to the right. Now another way to check to make sure we have it is, because again, the way we interpret lines is from left to right. And if I'm going from this point here at the y-intercept down to this one here, am I going in a positive or negative direction? It's negative, it's going down, yes? Now say I put it over here. Well, again, we're reading from left to right, yes? So the green point would be first, and then I would go to the y-intercept. Is it going up or down? It's now going up, yes? Which would be not negative, but a positive slope. So it can't be this one here. Now we can do the same thing again. So I can go down 2 and over 1 to the right. And we can keep going in this direction. Down 2 over 1. And we get this equation, or this line here. Okay. So we have one of our lines. Are there any questions on this so far? Okay, let's look at the other equation. So what's the slope? And the y-intercept is -2 and -2. So this one here, I start at -2, yes? Where do I go from here? So I can go up 2, and then I would go to the left or to the right. Because again, the slope is positive or negative? Negative. So if I went up, I'm going to what? Positive or negative? Positive. So up is positive. So I went in a positive direction, yes? But the slope is what? So I have to go in a negative direction next, which would be to the left. Because if I go down 2, 1, 2, that's a negative direction. To keep the slope negative, I need to go where next? To the right. I need to go in a positive direction, which would be right here. Wait a minute, did those cross? Would these ever cross? Mm-mm. They're parallel, because if the slopes are the same, the lines are parallel. So this here would be a no solution. It is a no solution. Because if the slopes are the same, they will never cross. Questions on this here? Are there any questions on any of this here? Do y'all feel comfortable with this? Okay. So we'll stop here, and I will let y'all have time to work.